For 3E, we're going to do a ratio test. It looks like it lends itself to a ratio test, so we're going to set this up. So we're going to have our n plus 1 term, so it looks like this, 2 to the power 2n plus 2 factorial over 6 to the power n plus 1, and then we end up with n plus 1 factorial, and then we're going to square that. Okay, that's 2n plus 2 because remember we're substituting n plus 1 and then timesing that all by 2. In the denominator, we end up with 2 to the power 2n factorial over 6n, then n factorial squared. Okay, so that's our starting point. We want to group some of these terms, so limit as n approaches infinity. Just going to put this in one fraction. So we're going to start with the 2n plus 2 factorial, and I'm going to group that with the 2n factorial. So it's going to look like this, 2n plus 2, 2n plus 1, and then 2n factorial. So that's going to be the same as that term. I'm going to group this in green here. In the denominator, I'm going to have the 2n factorial. That's the blue term here, so 2n factorial. So those are going to cancel out. I'm going to group that. That's all going to be one grouping. I'm going to group the 6 to the power n plus 1. So it's going to look like this. It's going to be 6 to the power n in the numerator, 6 to the power n in the numerator, and then in the denominator we have 6 to the power n, and then that plus 1 is going to show up as a times 6. Okay, and you can see that we have some terms that are going to cancel out here. And then lastly, we have, I may have to move some of this over a little bit so it makes some room. Okay, so I'm going to group together my n plus 1 factorial squared with the n factorial squared. So it's going to look like this. I'm going to start with the numerator, n factorial squared. And then in the denominator, I'm going to write this as n plus 1 times n factorial. So we end up with n plus 1 times n factorial. So that's going to be the same as n plus 1 factorial. And then I'm going to square all of that. And I'm going to group that in blue. Okay, and there's my ratio test. So there's lots of things that are going to cancel out here. So we have a 2n factorial canceling here. 6 to the power n is going to cancel here. Here we're going to have n factorial squared cancel with the n factorial squared here. So what's left? So we have the limit as n approaches infinity, and the terms that are left here. So we're going to end up with 2n plus 2. So keep that consistent. We group that in green, so I'm going to write this as 2n plus 2 times 2n plus 1. In the denominator, we have left over an extra factor of 6 and an extra factor of, looks like, oops, in blue, in the blue brackets, what's left over is going to be n plus 1 squared. Okay, I'm just going to shorten this up a bit. That's all the terms that are left. And now I can apply my limit. My limit is going to be, well, if the numerator is going to have the highest degree is going to be n squared, so we're going to have 4n squared. In the denominator, we're going to have 6n squared. So we end up with 4n squared over 6n squared. Simplifies to 4 over 6. Okay, so this is, our limit is equal to 2/3. Okay, I can keep the absolute value. Actually, I don't need the absolute value anymore since we know that that's a positive value. And we know that what we're looking for is less than 1. So that's true. So this is convergent.